Well, welcome everybody. It's 2:05, so we'll get started. It's lovely to have you all join us. And Shane and I are thrilled to be putting this workshop on. I'm going to introduce everybody to you if you don't know who we are yet. But what we're going to be talking about today is how to use Jupyter Notebooks inside of Pro, which is a big game changer really recently in desktop and web-based GIS. So we're really excited to have you join us here. The first thing I want to tell you about is who we are and who we represent. I know this is UC Data Love Week, and we're all part of UC. The particular group that this group who's putting on the workshop is part of is University of California Division of Agriculture and Natural Resources. We are a statewide network of folks in cooperative extension offices, research and extension centers, and affiliated UC campuses. We're a network of people across the state who connect the power of UC research with local communities. And we have a range of statewide programs that we run. You might have heard of some of them: CalFresh, UC IPM, Integrated Pest Management, California Naturalist, all of these amazing powerhouses that focus on things like nutrition or youth development or natural resources or agriculture. And one of those statewide programs is ours, mine. It's called Informatics and GIS. And our goal is to help you, and not just everybody in the network, but really anybody. We do focus on UC, helping you integrate cutting edge geospatial tools into your work. And we do that through trainings like this one. We have a service center where we help people with projects. We do applied research, and we fly a lot of drones. So if you're interested in any of this following the workshop, please check out our website and be in touch. And who we are particularly is myself. I'm the director of the ArcGIS program, Maggie Kelly. And Shane Fire is going to be running the workshop, the hands-on portion of the workshop. So you'll be interacting most with us too, but behind the scenes, you're also going to have Andy Lyons, Robert Johnson, and Sean Hogan there to help you in case there are any glitches that come up or you're not sure what's going on. You can use the chat. If there's a big problem, we can pull you into a breakout room and see what's going on. So yeah, we're here. We love working with you guys, hearing what you're up to, and teaching new skills. So who you are is fun. You're all over the place. There's a lot of you from California. There's some from other states as well. And as a icebreaker to these workshops, we always ask you if you can do this. So in the chat, can you put your name, short, brief, what you want to get out of this workshop, and your experience with Python or Jupyter Notebooks from 1 to 5. Just let's do a roll here, see what we've got. So anybody want to kick it off? All right, we got a ringer here, and Shane. Anybody else? I love this part, really helps me think about who we're talking to, so don't be shy. Hey, Annette, great. Love beginners. This is going to be a fun afternoon for you. Anybody else brave enough to let us know? Great. Hey, Charlotte, you're a 2. Love it. Sean, 2.5 to 3, getting there. Great. Good. We got a couple 1s. Ooh, good. Aminder is a 3-4, Yifei 2, Rhonda, super 1. Want an overview of ArcGIS. Rhonda, we might also have some other workshops for you. I'll mention them later if you want to keep with this, because we do some intro to GIS stuff that might be of use to you. We'll keep those going. This is really helpful. Okay. All right. Beginner in ArcPi. Love it. You're going to take to this like a fish to water. So what we're going to do today is we're going to do introductions. We've already done them. I'm going to talk a little bit about why notebooks, what are they, some basics about linking them within Esri products. We'll do some basic definitions, and then a couple of examples of what all this is going to look like. But then the bulk of this afternoon, for obvious reasons, we're going to dive into this workshop. And Shane's going to run that. He's a real Python pro. He's also a pro, forgive the pun. And so you're in really good hands there. We're going to talk about Python basics, explore ArcGIS Pro, look at how we use the history function to get started on bringing reproducibility into your work, open up a notebook, explore spatial data, interact with this particular data API that we're involved in called KalAdapt to find and analyze climate data. So it's going to be a ton of fun. All right. So let's, I'll kick off a little bit more with some background. So if you are an Esri user, or if you're familiar with Esri, you know that right now the Esri Universe consists of the desktop software, which is called ArcGIS Pro, tremendously powerful. You download it, install it on your computer. ArcGIS or Esri also has ArcGIS Online, and that's the web version. So you don't need to download the software. You can do all of what you need to do through a browser. I'll talk a little bit more about differences between these two, but that's the base program. But a lot of times we want to get outside of that universe. We want to bridge to something else. We might want to ingest our data or push data from our GIS to R, or push our imagery to something like TensorFlow to do some machine learning tools. Or we might want to interact with APIs like iNaturalist or KalAdapt. And there used to be something called, well, there still is, one way to do that was something called R-Bridge, where you could form a bridge from the Esri world to R. There's also, ArcGIS has APIs that you can work directly with Python through the API. But recently, Esri has incorporated notebooks, these Jupyter notebooks within Pro and within ArcGIS Online to allow you to do coding and build reproducible workflows. So it's been a real game changer, like I said at the beginning. And so why would you want to use notebooks in your GIS workflow? You might want to stop you doing the same tasks over and over again with a button. You might want to, with a mouse and a click. You might be sick of that. You might want to work faster. You might want to save your hands from carpal tunnel, which it gets to be a problem. You might want to send code to your colleagues so that you can collaborate. You might want to automate quick tasks and writing scripts that perform a few steps quickly and effectively. And you might want to work in a coding environment to ensure reproducibility. All of those, and there are other reasons, but all of those are reasons why you might want to start embracing this concept of notebooks. They're amazing. They do a ton of great stuff. There are some things that notebooks or coding don't do well. So sometimes if you do have to do manual digitization, you have to collect things in a very detailed way. Sometimes that can be difficult to code. Some fine tuning of design work and kind of cartographic production can be not difficult, but less, well, can be more difficult with coding. Sometimes coding has a steep learning curve. And sometimes coding languages can seem intimidating or confusing. And that's what we're going to try to break down today to get you started. But at the basic, you want to think about scripting or coding as a recipe. It's just like you are planning your, what am I going to cook on Saturday? You get a recipe, you get the ingredients, you have a set of instructions that you follow for what to do with the ingredients. And so this sort of environment is going to help you perform a large number of workflows in spatial data science, in GIS, and machine learning. All kinds of stuff are going to be made easier with scripting. But it's just think of it as what am I going to cook this weekend? And what's the recipe? What's the ingredients? How do I follow it? And before we launch in a couple of definitions, we're going to talk a lot about Python today. We're going to talk about Python packages, and those are just a collection of modules that want to run something like pandas or NumPy or SciPy. A library is a collection of those packages. A package manager is a software bundle that installs Python and associated packages like Conda or pip. And if all of this doesn't make sense now, don't worry. We're gonna walk you through it. But I just wanted you to have all these things sort of spelled out. And a Python environment is an installation on your computer with Python and all the associated packages. And Esri has a particular Python environment that you're going to be interacting with, and it's called ArcGIS Pro Pi 3 environment. And you might have never seen this or interacted with it in using Pro. Doesn't matter. We're going to show you what sort of things you can do with it today. All right, so what is this Jupyter thing about anyway, and what's with this crazy spelling? So Jupyter is a loose acronym that combines Julia, which is a scripting language that a lot of astronomers use, Python, and R, so Jupyter. But today, the notebook technology supports many program languages, and what they are web-based interactive computing platform and open document format that allows you to combine code, equations, text, other rich media. It's a little package, and I'll show you what it looks like, that just, for you scripters out there, it's going to look really familiar. For you non-scripters out there, it's just that recipe. It's like, first line, do this, next line, do this, but you can also add text, comments, this sort of stuff. And, it supports multiple programming languages, so it's pretty cool. And this guy, Fernando Perez, is the one who pioneered Jupyter Notebooks. He's at Berkeley, he's in the statistics department and part of the Berkeley Institute for Data Science. And it's really come a long way since its development. So most of us right now interact with Pro or interact with a GIS software using a GUI, which means we got a mouse, we got our hands, we click on something, we right click on it, we point at a tool, we fill in a box. It's this sort of very interactive one-off way of doing GIS, and it's perfectly legit. But when you have a ton of things to do and you're repeating yourself over and over, it's a time to think about doing scripting. So we can interact with a GUI, or we can start scripting. And one way to use Python or scripting within Pro is via ArcPi. And for those of you who are familiar with Pro, this is a little clip of the ribbon at the top of your ArcGIS Pro software when you're running it. And this is the left-hand side of the ribbon. And you can see here that we have the ability to open up a Python window, and we can start typing in Python code, or we can grab existing Python code from the ArcGIS help, or we can use our history, which I'm going to mention in a bit, and so is Shane, to turn something that we've done using a GUI into a script. So Python was introduced nearly 20 years ago, and it's really been a screaming success. But we can also interact with Python within Pro using notebooks. And so notebooks are this Jupyter notebook-like environment that comes pre-baked. So every time you install Pro, it comes pre-baked with a ton of Python packages and libraries. You got core Python functionality, standard library, ArcPi, ArcGIS API for Python, lots and lots and lots of other stuff. And if you want to install somebody else's or do something additional, you can do so by interacting with those environments that I mentioned at the beginning. So when you first open Pro, you see something that looks like this, and oftentimes we just go straight to new or open. But if you cruise down there, you see it says Python, and you can actually install new packages. You can really work with that environment by cloning it and mucking around with it how you want. So Shane's going to talk more about that as well. So you can access Python inside ArcGIS Pro using the Python window or the notebooks, you also can access Python outside of ArcGIS Pro through Python command line, or using something like idle, or using Jupyter notebooks on the web separate from Pro. But what we're going to do today is think about how to use them within Pro. And what do they look like? This is the ArcGIS Pro snapshot that I showed you before, where I was doing some work with Shane, looking at pulling data down from iNaturalist. So there's my map, there's my table of contents on the left, there's my catalog on the right, there's all my tools across the top of the ribbon. This should look pretty familiar. And if you see here, I've got two tabs. One says map and one says notebook. And that notebook is just a list of code, and it's organized by cells, which is great for decoding. So you run it cell at a time. Does this cell work? Success. Does the next cell work? Success. And all that is just Python language and some comments to help me go out to iNaturalist, grab some data, bring it back, clip it, map it, the rest, yeah, that sort of stuff. Shane's going to talk about this. This is has been my favorite thing to learn about, is the history. So you always can look at your history and it'll tell you what you've recently run. Clip, I added a field, I created a feature, I created a file geodatabase, you know, in the opposite order. Each one of those you can right click on and get the Python code, or you can turn the whole thing into a script. So it's a great way to start thinking about interacting with Python. And Shane will talk more about this. Recently, used to be if you wanted to do scripting, you had to stay in Pro on the local desktop installation. But recently, Esri has included notebook accessibility in ArcGIS Online, which is kind of mind-blowing. So you can write and share your Jupyter notebooks within ArcGIS Online. You can use the stuff that you're going to learn today could be used in ArcGIS Online. One caveat is, if you do need to install different third-party Python packages, you can't do that in ArcGIS notebooks. You have to do that in Pro, which makes sense because, yeah. So, but anyway, what do they look like in ArcGIS Online? At the top, which is sort of equivalent to the ribbon, instead of home, gallery, map, scene, groups, context, content, organization, now they've added this tab, notebook, which is pretty cool.
Hey, Meg,
last thing, yeah.
Can I add one thing about that last slide?
Yeah.
If you have ArcGIS Online for organizations, you may not see notebook unless your administrator has given you the notebook role. So if you want that, you need to contact your administrator to get access.
Perfect. Thank you. So before I'm going to wrap up, I just want to kind of close with this, again, bigger picture about the Esri universe. It's based on these two platforms. One is the local one, ArcGIS Pro. That's the one you download, you install on your computer. One is in the cloud, ArcGIS Online. There are great benefits to each. They do very similar things, but there are some slight differences. ArcGIS Online, you can create web maps, web apps, links to loads of very cool apps like story maps or field maps, simple analysis, although that's changing. It's getting better and better every week. It's very fast. It's very intuitive. It's browser-based, so you don't need to, download a piece of software and have a license. And you have to have a license, but you don't have to download the software and install it. Strengths of Pro, really good control of cartography and design. If projections are important to you, you should start in Pro. There's a lot of advanced analysis, image processing, spatial modeling, UAV, LiDAR work, and it is still probably the preferred domain if you're working in reproducibility or coding. But like I said, that's coming to ArcGIS Online. But both of these have access to phenomenal amounts of data, which is really, really terrific. Okay, so I'm going to close and turn over to Shane, but we do have a lot of other workshops in the docket. If you're interested, here's the website here. We could put it in the chat. We do these, every spring, every fall. We've got a ton of these workshops. So if you want to capture field data, if you want to deep dive into spatial analysis or story maps or, what have you, check it out. And we're thrilled that you would join us today. So on to the workshop. We're going to have a quick break here before we kick off. Check your emails for any messages. Sean sent one out earlier. If you're having any trouble, reach out in the chat window. And Shane, I think you are up.
That sounds right. And are we gonna, you said a brief break, so 2:30?
Up to you. Totally up to you. What would you like to do?
Let's do a brief break until 2:30.
Okay.
And then we'll come back.
All right. 2:30 it is.
Let's get started here, everyone. So once again, my name is Shane Fire. I am with the, as Maggie said, the Informatics and GIS group at UCANR. And my specialty is GIS, and I've been doing GIS for 20 some odd years. And I have seen Python come into the use on GIS. And I will tell you that I use Jupyter notebooks and Python every day in my daily activities as a GIS analyst. I have found that Jupyter notebooks have really simplified a lot of the things I do, and I'm able to very easily script out ArcGIS processes and other things using Python. So hopefully what you gain from today will be useful for you, and let's get started. And also, as this slide says, please check your email and reach out to the team in chat if you get stuck. And if something they can't answer, they'll reach out to me and I'll try to address it on the call as we're going. So what we're going to talk about today is how to access Python and Jupyter notebooks that are installed by ArcGIS. Some of you may have Python installed in other ways by using Conda or Anaconda. And what I'm going to do is show you how to access the Python environments that ArcGIS Online installs, sorry, not ArcGIS Online, but ArcGIS installs when you install the program. And then we're going to get into actually using Jupyter notebooks inside of ArcGIS Pro. We're going to show how you can automate workflows, perform geoprocessing tasks, how to create data summaries, and then how to work with KalAdapt data from the KalAdapt API, as well as the KalAdapt data server. So let's get going. So how do you access Python on your Windows desktop? You can do it both inside and outside of ArcGIS Pro. So let me show you how do you do that. It's really quite straightforward. So if you can see my screen, the first way to actually see and access ArcGIS, excuse me, I'm going to keep saying ArcGIS, I apologize. To access Python outside of ArcGIS Pro is just go to Start menu and start typing Python, and then Python and command prompt. And if it doesn't show up like it should, for some reason my computer is not agreeing with me. If you come up here and you say apps, go all apps, go down to where you see ArcGIS, and what you'll see here is a Python command prompt. If you click on Python command prompt, it'll open up and you can see that you are in a Python command prompt, and you can see your current active environment or your Python environment. In my case, I have one that's been cloned and it's called Deep Learning. And that's actually the Python command prompt that I'll be using with this environment. So you could actually, right from here, you could very easily start up Python itself just by typing the word Python. And the Python shell will open up inside this command prompt. And you could type any normal Python command inside of here, and you would get a result, and it works just like in any other shell. So this would be my name. And you can see if I enter that, it prints my name. If you do this and you want to get out of the command, Python shell, type the word quit, open close parens, and it'll kick you back out to the command prompt. So I don't use the command prompt like I just showed you very often because it's not really easy to edit and derive code inside of there. Outside of ArcGIS Pro, you have two options. You can actually three, you can do this, or you can use idle, which is shipped with Esri since the ArcGIS desktop when it first came out. And it still ships with the with Python. And to access idle easily is you open up the Python command prompt like we see here, and then just type the word idle. And that'll open up the Python shell. And here, once again, you could type in, like I just did earlier, I could type in Trent, Shane, and hit enter. It'll give you the immediate output of that. But here you can also start up and you can actually create a new file. You could save this as a Python file and write your code. It's not as easy to code in the IDL shell or the development environment here. So I use this often when I've already developed a script and I need to make some minor modifications and I'm ready to put it into production. I'll use idle to make minor tweaks. And if I close this down, you'll see that it closes it in the program and it goes away. So I'm going to close this though. And the third way you can actually get access to Python that's installed by ArcGIS, but get access to it outside of ArcGIS, is to actually open up Jupyter Notebooks separate from ArcGIS Pro. So once again, if I go to the ArcGIS folder, what I'll see is a item called Jupyter Notebook. And if I click on that, it's actually going to start the Jupyter Notebook server in a command in a prompt, and it's going to open in your browser, and you are going to see your user directory on your Windows machine. So this would be my directory, and you can see all the different things that are there. And at this point, if I had a Jupyter Notebook in here, I could open it. I can also go in and create a new Jupyter Notebook. You can see I hit new, Python 3, whatever else I need, and it'll actually open a notebook and I can execute code within here, just like I would inside of ArcGIS Pro. There are pros and cons to doing it here. By doing it here, you don't have tight integration that you have when you do it inside of Pro, but it's a little bit easier to manage packages and stuff if you use it here. But we won't go too much into detail on that. So you open it up, and one thing, and you'll have the exact same options inside of the notebook inside of Pro. You'll have edit, view, insert, cell, help. And one thing that's really important to notice is you have this little mini keyboard. And in here, you can get a lot of codes, a lot of helper codes that you can run. So in this case, I want to close this, this page. I can actually shut down the kernel and close it, or I can shut the page. And I'm actually going to shut down the kernel and close the window because I'm not going to do anything in here. So now I've actually left that kernel, and now I'm back to the main page, and I'm going to quit this. So, and one of the handouts that you were able to download today in the last email you received actually highlights these different methods to get access to ArcGIS. I'm sorry, to get access to Python outside of ArcGIS Pro. So now though, I'm going to show you how to get access to it inside of Pro. But we're going to hold off on that until we get into Pro itself. If I go back to the presentation, so there's how you work with it outside of Pro. We're not going to do any more of that here. But what we're really going to get into today is we're going to open up a project package that you got a link to in the email. We're going to open that up, and it's going to open inside of Pro, and it's going to come with 4 Jupyter notebooks or Python notebooks included. The first of those notebooks is going to be Python Basics. For those of you who aren't very familiar with Python, I think this would be very helpful. It's going to go through variables, lists, tuples, how to do different types of loops, how to create custom functions, basic things that as a new person to Python, you're going to want to know how to do. So we tried to put it in one notebook so you could see all those different things. The second notebook you're going to see is this is actually the first notebook that's going to deal with ArcGIS Pro, and it's going to show you how to use the geoprocessing tools, how to get access to the history, and really how to plot data and use pandas to look at more of your data in using different third-party packages. The third notebook is going to get into using the KalAdapt API and the KalAdapt Python toolbox that I developed for use with the KalAdapt API. And this is going to use, it's going to query the KalAdapt API to bring back information from that API and graph the results. And the fourth, if we get there, there's a lot of information here. If we get to number 4, and you'll have all the code for it, is going to be how to use a notebook inside of ArcGIS Pro and the KalAdapt Python toolbox inside of a Jupyter notebook to query the data server from KalAdapt, pull back NetCDF data, and actually work with NetCDF data for the entire state, and do more individual analyses, custom analysis looking at the entire state of California, all the way back from 1950 with climatic data all the way to year 2100. So hopefully we get to this one. We'll see what we can do. So with that, let's start digging a little more into what we're going to do today and actually get into ArcGIS Pro. So one thing that you should have downloaded today already is a link that we gave to a ArcGIS project package. Here it's called ArcGIS Notebook Workbook, and it's a PPKX file. If you click on that file, what it's going to do on the back end is it's going to basically uncompress it, put it on a location on your computer, and start ArcGIS Pro into that package. And in that package, you're going to see the 4 notebooks I just mentioned, as well as a map with some basic data in it. And it's already going to come preloaded with the KalAdapt Python toolbox that we're going to be using on notebook number 3 and 4. So right here, Maggie had mentioned about how you can access notebooks inside of ArcGIS Pro. So what you can do is, if you go up to the analysis toolbar, if you don't have a notebook in Pro, you can add it from the analysis toolbar. You can also open I should mention, a Python window within ArcGIS Pro. This existed in ArcMap as well. If I was to open that up, you'll see there's a Python window opens up at the bottom of the screen. Just like before, I can write directly to it. This is a Python immediate window. So as I type, once again, my name, and I hit enter, it'll actually immediately show you the results. One thing also about this and the notebook inside of ArcGIS Pro, it does have the equivalent of IntelliSense built into it. So if I start typing ArcGIS Pro and I forget where I wanted to go, or I'm wondering about syntax, it'll actually let you go in and start figuring out what you want to do. So I can go in and say, oh, I'm interested in raster, the raster function. And I can go in, or actually the raster module, I can go in, and I believe if I hit a question mark, it'll actually query that and come back with the help for the ArcPi raster. It did not like that. Okay, 1 second. If you type help and then in parens put what you're looking for, it'll give you the syntax for the raster. And what this does is it allows you to load a raster into memory so you can work with it. But you can do all this from the Python window. I don't use the Python window very often. I mostly use that for testing code before I move it up into the Jupyter notebook. So once again, if you want to add a Jupyter notebook, you can come up to Python, you can hit this button here. It'll create a new notebook, or you can add it. You can, oh, it's not going to let you, you're going to have to add it. It'll create a new notebook. It'll add it to your project. If I go to catalog, notebooks, you'll see a new notebook's created. And now this is a notebook inside of ArcGIS Pro. If you want to add one, you can do it in several ways, but the easiest is to either go up to notebook, analysis, Python. It's not giving me the add option. Over here on the notebook in the catalog, if I right click on the notebooks folder, I can right click and say add notebook. If you have one in your current folder, you can also just drag it up and it'll add it to that notebook folder as well and make it available for your project. So those are the different ways that get access to notebooks. But now what we're going to do is we're going to delve into the first Python notebook that I mentioned. That is all the Python basics. So we're not going to deal with this map yet. We will eventually. But if you were to click on Python basics, and if you open that up, So this is a notebook. One thing nice about Notebook, there's several things. First off, you can use Markdown. So you can actually have, you can have other text beyond codes. You can have Markdown text. You can also have headings, and you can have your code. Once again, here is the other options, and it's searchable, so you can figure out different things you can do. You can close and restart your kernel by using this. You can go in and you can save your notebook if you have an issue with things locking up on you. This is a really helpful little icon to know about. Also, one thing to keep in mind is as you're writing your code, you may have an opportunity where you just want to test everything. What you can do is go up here to cell and you can say run all below, or whatever you want to do. And it'll run everything in your notebook as long as there's no errors. So let's get started and actually use one of these notebooks. Okay, I just saw that it would help if I'd be a little bit slower. I apologize. I will slow down. Okay, let me see also if I can shrink my Windows ArcGIS Pro a little bit to give more, to make it look better on your screen. Give me 1 second. And please let me know if it's better when I'm done. Is that better? Can you all see the screen a little bit? It's a little bit clearer now.
That's better.
Okay, thank you. Thank you. Okay, so the first notebook, we're just going to go through the basics. And as Maggie mentioned, you have each individual cell and you write your code inside of a cell. So in this example, what we're going to do is we're going to just define some basic things about Python. And here we're going to look at variables. So variables are how you pass information back and forth to Python, to the Python interpreter. So there are many different types of variables, but ones that we frequently use are going to be strings, integers, floats, and Boolean. And when I say Boolean, I mean true and or false. So if you want to make a string variable, it's as simple as the name you want it to be defined, such as here, name. Okay, Rhonda, you just asked how I got to Python basics. If you go to the catalog pane, and the way to get there is if it's not up, is go view and then go to catalog pane. It'll open up this window on your right-hand side. Underneath there's a notebook. You'll see notebooks that is collapsed. Expand that and you should see Python basics.
So let's take a break here and see if anybody else needs to get to where we are, because
that's a good idea.
Yeah.
Not seeing notebooks. Did you open the project package?
So maybe walk through it again, just from the beginning.
Yeah, I can definitely do that. So let me.
Anybody else? Is everybody else where Shane is? Can you give me a thumbs up or a okay, we got one thumbs up. Okay, good. Looks like most people are. So let's just go through it one more time for the folks who don't have thumbs up.
Will do. So I'm not going to share my screen, but you click on the file because I'll have to resize it when I'm done. But if you click on the PPX file, it should open up ArcGIS Pro. And when it opens up ArcGIS Pro, you should see.
Yeah, we got a tip here about pro versioning that might be helpful.
Ooh, what's the tip?
I think certain versions of Arc Pro may not support notebooks. So if you're on an older version, it may not support notebooks. I'm on 2.7 and it threw out a warning saying like, hey, this was built on 2.9. But I think like anything below 2.7 may throw out an error.
Okay, that's a good note. Yeah, I'm using the newest version of ArcGIS Pro, and I believe, like you were saying, this was developed on 2.9 in the fall.
So
One nice thing about Pro, though, is that it is updatable. It asks you to update on a regular basis. The only issue about doing that is if you have custom programming, custom environments, you sometimes have to recreate those environments after you update your version of Pro.
So Rhonda, can you, is that the answer? Is that your issue? Are
Yeah.
you in a different version? Okay, you're starting again. Great. And if it happens again, we can pull you, maybe Robert or Sean can pull you into a breakout room and go through it.
Thank you, Maggie. That's a great idea.
Yeah.
And one thing, Rhonda, if you get to the point where you need to figure out what version you have, go up to Project and then go down to About, and it should tell you what version of Pro you're using. So I'm going to keep, what's that?
I did have this, I just checked this. It is a versioning effect. I just looked on my remote desktop and it's like that on one of the remote computers. So
That's an
with
earlier version.
Yeah, it seems to be an earlier version.
Okay.
Okay. Yeah. So, yeah, that changes things a little bit. So if you do have access to the Python basics, or Rhonda, if you're able to upgrade to a newer version of Pro, when you open up Python basics, you'll see that it'll open up. And like I was saying, we're down at variables. So I'm able to set my name. And as long as the variable's inside quotes, single or double, Python treats it as a string variable. So in this case, if I say print, it's actually going to print. It's going to print my name. And then you'll also notice I want to point out that I said print, it did it for me. But also in Jupyter Notebooks or Notebooks in ArcGIS Pro, if you just type the variable and you don't say print, it'll still display what's in the variable. So then, that's an easy way to set a string variable. Then if you want to set a numeric variable, in this case, I'm setting a variable called num, and I'm just typing in 20. If I hit enter, it's going to create a variable called 20. It's going to be an integer value. And you can see I can do some basic math with that. And I'm multiplying num by 2, and I'm printing the result, and it equals 40, which you would expect just by doing simple math with a number variable. Numeric variable. The other thing I want to show you is Boolean variables. So Booleans are true and false, and often you'll have a case where you need to do a test. Is something true? Is something false? You can explicitly define something as true or false, and you can see that here on line 1, where I'm saying choice equals true. I will point out that a lowercase true is not a Boolean variable in Python. It has to be uppercase. Capital TRUE, and same with false. So in this case, because I set it equal to true, it's going to say choice is true. If I was to change this and make it false, the if statement would then evaluate and say that it was false and give me the output. Up above here, I mentioned that this number came in as an integer. And you can see that here when I talk about integers explicitly. So number 10 is an integer. And if I run that, what you're going to see is and if I look at the type, so I say, what type is num? It's going to say it's an integer. The way to define a floating point in Python is as simple as just saying 0.1, 0.0 is actually just placing a decimal place. And now if I run that, it's going to see that it's a floating point. It's a float data type. So 5.1. And the way to convert a float to an integer, what you'll see is if you use int and say num1, it'll turn it back into an integer by just truncating off what was right of the decimal place. Ooh, I just saw that Christy mentioned that ArcGIS Pro is at least has to be 2.5 for notebook integration.
Also, so just in case anyone was wondering, I am one of the Esri managers at UCSB. So if your campus did that license server update to like 2021, 2022, it does support Arc Pro 2.9. But if you have not done a license server, and if you're on a concurrent license, you may not want to make that jump to 2.9 right now, because it'll depend on whether your license server will support Arc Pro 2.9. 2.8 is okay, but 2.9, we've been seeing it has to be updated to the most recent server that Esri just pushed out recently, I guess. But yeah, that's one issue we've been running into.
This is very helpful, Christy, because we have so many people from so many different campuses, and so it's kind of like a patchwork right now.
Oh, okay, yeah.
Yeah, so normally it's just, well, anyway, this is great info. We'll incorporate this into our next version of this.
That is great info, and we haven't run into that in our group because we get our licenses through ArcGIS Online instead of a license server, so we don't have that issue. So thank you for bringing that up, Chris.
Yeah, named user licenses and single user licenses shouldn't have the issue of using Arc Pro 2.9, but if you're on a concurrent license which means you're getting your license from a server, you may run into issues automatically updating to Pro if your server isn't updated for that.
Makes sense. Thank you. So then, as you can see, you can easily define variables such as a floating point by just specifying a decimal. And you see that again on this line, but on the next line I've highlighted. If you run that, you'll see that it's by just saying 10.0, it becomes a floating number. I can ask for the type again, and it tells me it's a float. I can then do an integer, but I can also convert that integer also to a float by using the float method. And it turns it into a float with 5.0. So there's ways to convert numbers back and forth. Numbers can also be defined using scientific notation. I just don't have an example here. One thing to note is strings. You can define strings by both single and double quotes. You can't mix them. You can't have the first one be a single or double and the last being the other. They have to be the same, and they have to in order for them to work properly. But here you can see a single quote works and a double quote works. Often when you're programming, there are needs to concatenate strings and numbers. There are several different ways to do it. And with different versions of Python, there are more Pythonic ways and newer ways. I'm just going to show you two right now. The first one is just how to join two strings. And an easy way to do it is by using the plus operator. Notice here that I added an extra space, so they're spaced apart. If I run this, it says, howdy partner, what you'd expect. The next one, however, if I take a string, try to add a number, or in this case, an integer, and another string, it's going to give me an error. And that's because I can't concatenate an integer into strings. So the way to get around that is I need to convert that integer into a string value before I concatenate the numbers together. And now if I do that, you can see it does work. One way that I've been using more frequently in the last couple of years, instead of doing the simple AND operator to combine it together, is I basically use string formatting. So here what I've done is you define the string that you want to insert your text into. And I use right here the %s. And whatever I put in here as my variable is going to get inserted in where that $s is. So here's the string that I want to insert into. This tells it to insert at the %, and it's going to be a string value. And here's what I want to insert in. So it'd be outstanding. So it should say, I'm feeling really outstanding today. If I run that, it does exactly that. One thing nice about this method is you can do more than one, and it can also be different variable types. So if I was to run this with two variables, you see I have the %s in two places. You have to have as many arguments passed into this as you have placeholders. So I have two placeholders, I have two arguments. If I run this, I'm going to see 1 is smaller than 2. One nice thing about it is if I use an integer in here, it'll convert it to a string and insert it into the text. It's really straightforward. So I use substitution like this often when I'm trying to concatenate and create path names, and you'll see that in the code. When I need to insert variables inside of commands and geoprocessing tasks inside of ArcPi, things like that, I'm often using this methodology. Also, a frequent thing is you need to be able to loop through sequences. So two of the main sequence types we're going to use inside of that you'll end up using inside of Python is either going to be a list or a tuple or a range. A list is a series of values enclosed by square brackets. These values can be mixed types. They don't all have to be string. They don't all have to be integers or anything. They just have to be separated by columns and enclosed with square brackets. One thing about lists is they're mutable, which means you can sort them, you can add things to them, you can remove things. They're actually really versatile and they're used a lot. In this case, if I print this, you're going to see it's a list. It's going to be foobar, baz, cucks. So it's just those different words I put in there. And like I said, you can sort it. So if I run this and sort, it sorts it out accordingly. And also you can iterate over something. So in this case, I'm going to use a for loop. I'm going to say for I in, and in is going to be the list. So it's going to loop through everything in the list. And I'm saying print I. If I do that, it prints out everything in that sorted list. Really straightforward, it works well. Nice thing about lists in Python in general is you can slice lists, you can slice objects in general. So here I'm going to slice the list and I'm going to say, give me the first value. This is going to be give me the last value. And then I'm going to say, give me the first and second and so forth. The one thing about Python that you'll run into is that Python is zero-based. What I mean by that is the first value in a list is 0, it's not 1. So that's important to keep in mind. If you're going in thinking it's based on 1 is the first, you're always going to skip that first value. And also when you specify the last value, in this case 0 through 1, it stops at that last number. It doesn't include the last number. So this is going to give us number 1, the first and the second, not the first, second, and third. Does that make sense?
Hey, Shane, I don't know if you answered Annette's question. It was from cell 11.
Oh, I'm sorry.
That's all right.
Oh, why didn't I use print? I could have, but because Notebook will automatically print out the last code if it's, in this case, it's just basically, just creating that output and printing it out. But you see here, it works, but you're right. You could have done a print. Oh, that ain't gonna work. You could have done a print and it would do it just like that. But one thing nice about notebooks are the last thing you enter in, it will print out for you.
Great.
So you could see how I'm able to slice and dice this. I'm able to bring in the first 2, the last, and so forth. But now let's take a look at tuples. And tuples are another sequence you can use. The big difference with tuples, beyond the fact that you create them with open and closed parentheses instead of square brackets, is you can't change them once they're created. You can't sort them. You can't remove items from them. They're immutable. So when you make a tuple, that's what you get. You can reassign something to that variable, but you can't change the tuple in place. So in this case, you can see I've got a tuple with, in this case, 6 values. If I run that, it shows all 6 values, just like you'd expect. I'm able to go in and say, give me the first, give me the last, give me the first 2. All those things work exactly the same as a list. And I can also loop over them just like a list. But what I can't do, and I can't do that, is sort. because tuples don't have the ability to sort because you can't change them. So that's one thing to keep in mind when you're using tuples. So I tend to use lists for things, unless I'm worried about the list being modified by a piece of code, then I would use a tuple. The other sequence I want to show you is ranges. I use range a lot. If you know the number of times you want to iterate over something, so that's when I would use a range. So in here I can say, I want to do this specific thing. I'm going to do it 10 times. So it's going to be 0 through 9, which would be 10. And so I'm going to say a range to 10. So it doesn't do the number 10, but it does it up to that, but not including. So if I run this, you're going to see 0 through 9. It does not do number 10. One nice thing also about ranges is you can start the initial value. So I want to do 1, and I want to go up to 11. So what that's going to do is it's actually going to give me more what you'd expect, which is going to be 1 through 10. So you can specify the beginning and the end. So here, 1 through 10. But also with ranges, you can specify a step. So you don't have to do it every individual. You could say do it every 2. So this is going to give me 5 values. But let's say I wanted to go to 100 values instead. I could go 100. And if I wanted to go by 5s, I could just change this and say, do it by 5. And now I have 5 through 100 by 5s. So it's really versatile in how you can do that. And there are different types of ranges you can do as well. I'm not going to get into it here and show you how, but you can do a date range as well. You could say, I want a beginning date and end date, and I want to increment monthly. And you can get a range of dates by doing the same thing, but it's not a range. It's a different function you have to use. So now we're just going to go over a couple more things before we shift into more ArcGIS Pro related things. So there's iterations and loops. You've seen me use the for loop quite a bit. It's kind of the workhorse of loops, at least in my opinion, and I use it all the time. So what we're going to do here is we're going to go through and we're going to loop a range, and you saw me do that before. And the basic syntax of a loop in Python is for, and this is going to be the variable that you're going to pass into the for loop. And in this case, range, and I'm saying give me range 10. So once again, this is going to be from 0 to 9. The really important thing about the loop, though, is you got to put the semicolon and then indent what you indent in, and then tell it what to do with the variable you're passing in this case, I. So here I'm just saying from 0 through 9, print out I. If I didn't have this semicolon there, I'd get an error. It's not going to be very descriptive, but it's going to say error. And if I didn't have this properly indented, and it'll try to indent for you, it'll also error because it expected an indentation. So that works. I don't use while loops often. So here's a for, here's an often something in other programming languages you might use more frequently, but it's a while loop. So do something until you meet a certain condition. Not a certain number of times or what's in a list, but in this case, you can see I'm doing a while loop, and I'm saying do it until as long as X is less than 10. So I initiate X to be 0. My loop says while X is less than 10, print X. And then inside that loop, I'm going to increment X. So if I run that, it should run from 0 through 9. And the reason you would do that is if you don't know the exact number of times you need to run something, but you know what the final condition you want to break to stop that loop. So you basically just tell it, go until you meet this requirement. Like I said, I don't use that as frequently. I use the for loop much more often. So conditional statements. This is something I use all the time. And if you're doing Python programming, you will as well. The basic conditional statement is an if statement. It's a if else, it's an if else or if elif else. So in this case, I'm going to do a for loop, and you can see I'm testing for a condition. So is I equal to 5, I want to have it tell me a different thing, print out a different type of text. So you can see here, so you've reached number 0 all the way through 4, then it hits 5, which is this case, and then it changed what it printed. The important thing to keep in mind, especially when you're doing a comparison with equals, is this right here. In Python, you have to say equals equals. If you say I equals 5, in this case, what that's going to do is it's going to try to set I equal to 5. It's going to set the variable instead of testing whether it's equal or not. So you have to do equals equals. Okay. So this is a simple case of else if. You don't have to have an else. You can just have an if. But just like with the for, you've got to have the semicolon. Otherwise, it does not know what you're trying to do. Thank you, Christy. That's exactly right. And then the other one here, we're just showing an example of using an elif, an elif. If you were doing JavaScript or another programming language, it would be else if, but in Python, it's elif. So you're saying, are you equal to 5? Do this. If you're equal to 6, do something different, else print the standard just like before. So you can see that you can really get selective on how you want to work with different values. And here's a basic structure for that. The last piece we're really going to get into beyond getting user input is functions. I use custom functions all the time. I'm often writing custom functions in cells in a Jupyter notebook and then referring to them later in the code. So in this example here, what I'm going to do is I'm going to create a function called list product. And here I'm passing in a list, and I'm going to multiply it by a value. In this case, I'm saying multiplier equals 1. I'm setting a default value. So just in case someone only passes in the list and no multiplier, it's going to go through and multiply by 1 unless they specify a value. And then if you go in here, you can see my product equals 0. I'm going to loop through the list, which I've showed you how to do above. And now I'm going to go in and I'm going to take each value in the list, multiply by the multiplier, so in this case 1, and add it to the product. It'll do that for each item. And then here's the important part of a function. I specify return the product or return the value from this function. And if I run this, you can see my, I didn't run this, hold on. If I run this code, the first time through, it's just going to add up to 10. I didn't specify a multiplier, so it just used 1. The second time I told it multiply by 10, and it did exactly that. It became 1,000. I could set any value here I want, and it'll, as long as it's a number, and it'll use that in its multiplication. I could say 1.1, it'll do exactly that. So it's really helpful to create default functions, and you'll see that in my code above, in my next notebooks. The last thing I want to talk about here, and this is just basic stuff, I don't use this that much, but you may find the need for it, and it's getting user input. So in Python, is if you preface something with input, such as here, input, and then what you're asking for, what the question is, the user will be asked for it, prompted. Whatever they type in will get assigned to the variable text. And in this case, how old are you? The same thing. And what you're going to notice here, when I run this, everything you get from the input is a string. So if I say, where do I live? I'll put in my location here. It says, oh, you just said Hopland. It's a string. It gets inserted in just like any other variable. If I ask how old I am, it says that I am 48 years old. But then if you look at the type for the age, even though I'm treating it like a number, as far as the input's concerned, it's text. So if you want to use the value as a number, you need to make sure that you convert it either to an integer or a float, such as this case right here. So if I go here and if I run this and it says, how old are you? It says I'm 48, and it says it's an integer value. So that's really the basis of getting user input. I often have used this in the past, something similar to this, to get username and passwords to use with ArcGIS Online in the Python API for ArcGIS. They actually have a custom function beyond input, but it works very similar. So those are the basics of working with Python, and you will use these a lot. when you're doing coding, whether it just be Python in general or in Jupyter notebooks. Any questions about that before we move to the next?
It might be a good time to have a bit of a quick break stretch.
Should we do a 5-minute?
Yeah, because
Yeah,
we've been going for 45 minutes and that was a lot of good stuff. So we'll take a 5-minute break. If you're having trouble, put it in the chat, pop in the chat. Let us know if you're up to where Shane is. And
absolutely.
I think after the break, we go into Pro.
We do.
Yay!
After the break, I call it the first notebook. It's where we're really getting in. We're doing, we're going to show how to use the history using a GUI, and then how to use that in the Jupyter notebook itself.
Okay, so it's 3:15, so back at 3:20.
That's perfect. And I'll be here to answer questions.
Yeah, you just hang out, and anybody just chat with Shane, let us know how you're doing, or just come back in 5 minutes.
Welcome back, everyone. Let's continue here. And the first thing I want to do is have everyone open up their map. So it's going to be just called map. And to do that, go to the maps folder in the catalog pane, expand it, and right click on map if it's not already open. Right click and say open. What you should see is 3 layers plus the world hillshade and world topographic map. If you open up, right click on select REX, which is research extension centers, and go to attribute table, you should see 2 research extension centers, Intermountain and Desert. And then under academic footprint home locations, there should be dots all over the state. On mine, there are not dots all over the state. So what I'm going to do is show you how to add the layer from ArcGIS Online and add it to ArcGIS Pro. So if you go to the chat window, I just added the name of the layer you're going to search for. So if you go in the catalog pane to portal, you'll see that in the upper right-hand corner. Choose the 4th item from the left or the 2nd from the right, ArcGIS. And you're going to search for academic footprint home locations. What you should see, and in my case, it's the first one, it's going to be academic footprint home locations. The owner is me. So it's stfire_ucanr.edu. And it's a hosted feature layer. If I right click on that and say add to current map, it will add it to the map. And now you will see points all over the state. And at this point, once you do that, hit save, just so you have it. And that is in the upper left-hand corner. And now we can continue with the notebook. So if we go in, we're going to open up first notebooks. This is the first time we're going to be interacting with ArcGIS Pro and Python. So if you open up the first notebook called number 2, first notebook, you can blame me for the naming. So the first thing we're going to do is going to walk you through using the graphical user interface to do the analysis. And then we're going to use ArcPi to do it as well. So the first thing we're going to do is we're going to do an intersect of counties and home locations. What that's going to do is it's going to give us a point location for everybody in that county, and it's going to tell you what county it is. So if we go and we go to, if we go up here to command search and we type in intersect, and the first option you're going to see is intersect analysis tool. Click on that. And this is what you should see. You're going to see input feature. It's going to give you the option to add more than one. You're going to give it a name and then make it happen from there. So what I'm going to say, what we're going to do is we're going to say input feature is ANR academic footprint home locations. And then the interesting. And then we're going to say California counties.
think you grabbed the wrong thing.
Did I grab the wrong thing, Rob?
I think so.
Okay, hold on. Something was just pointed out to me. Let me see if that's true.
Yeah, it's actually the one that's third from the bottom.
Thank you, Robert. So I was wrong. Go to third to the bottom. Add that. Is that what you got, Robert, as well? No, it's the same thing. So what we can do is we can actually just make it work easily is if you right click on it, go to properties, and we're going to assign the name to it. So it's academic footprint home locations. That'll be the name. And now if we go back to that geoprocessing tool, we're going to change the name to be academic home locations. And the output's going to be ANR footprint intersect. We're going to do all attributes, and we're going to keep it as the same as the input, which in this case, we want points. If I run this, it'll intersect the data and add a new layer to the table of contents on the left called ANR footprint intersect. And you can now see those data. If I was to look at the attribute table, you're now going to see name, titles, and also at the far right, you will see the county name, which is what we want. And then if I want to calculate statistics on the intersected data, I'm going to go up here once again to command search, and I'm going to search for summary statistics. And choose summary statistics. And what I'm going to choose as my input table is going to be ANR footprint intersect. The output table is going to be ANR footprint intersect stat. I won't change that. That's fine. What I'm going to count up, in this case, I'm going to do a count, is going to be academic title. And I want the count. So I'm going to change statistic type to count. You could do more if you want, but we're just going to do one. And then I'm going to do the equivalent of a group by. So if you've done database work before and you've done a group by query, in this tools case is what we're grouping by. So we're going to group by the county name, which is called name. And we're going to group by the academic symbol title, which will make sense in a second. It's going to be advisor, specialist, and others. So I set the tool up, and if I hit run, it'll then go in and I'll actually it'll add a table to your contents. If I open up that table, what you'll see is 147 records, records for each county with the symbolic title and then the counts. So the next step we're going to show is how to turn that into a chart using ArcGIS Pro. So if we right click on that table and we are going to say create chart, and we're going to create a bar chart. And then what we're going to do is we're going to say create a bar chart. We're going to have the category is going to be name. We're going to aggregate by count and symbol type. And then we're going to sort the x-axis, A to Z. So if I come here, category is, I think I said name. Is that what I just said? Yes. Name, count, and then split by symbol type. That don't look right. Oh, select, I want to choose the count field. And now what I should see is by each one, if I was to zoom in, you could see for each county, Lake County, here's the number of, in this case, advisors, education specialists, and people under recruitment in Lake County. You can see all those data. So you can see how that worked. And here's the resultant chart. Oh, I did a stack chart as well. Sorry. If I go back here, I open that up. if I was to go to the series, so I'm going to go in, I'm going to say data, then I'm going to go to series. So data, series. I don't want side by side, I want stacked. And then it's easier to read. And as you zoomed in, you could see all the counties, and you could see the total numbers of each type and the total for the county. But now what if you wanted to do all that with Jupyter Notebooks? So what we're going to do, and I'm going to show you the easy way to work with Jupyter Notebooks and the easy way to bring code over. So the first thing we're going to do is we're going to import the packages we're going to need to work with this notebook. And the first thing we're going to do is we're going to import pandas. We're going to import NumPy, matplotlib. ArcPi is already imported, if I'm right, by default, but we're going to import anyways just to be safe. And then this is the Python API for ArcGIS. We are also going to bring in the GIS module from that library. If we run this, it'll take a few seconds. And all of these packages are loaded by default in ArcGIS Pro inside of its default Python environment. They've now loaded, they're ready to be used. And now what I'm going to do is I'm going to tell it to use the licensing and the credentials that are being used in Pro to be used in the credentials for ArcGIS Online. And I'm going to tell it the current project is what I want to work with. I want to overwrite any of my outputs that I create. And my default directory is going to be that my workspace is going to be my default directory. If I run this line, it's going to set all those things. And now I'm ready to start working. So the first thing I want to do is I want to perform that intersection using ArcGIS. So you're probably thinking, well, how do I figure out the code for that? This is the thing where Maggie was talking about the history. The history is one of the best tools that I think Esri has put into ArcGIS Pro. They give you a lot of functionality. The one thing you can do is if I right-click any of these items, you have a bunch of options. You can save it as a Python script, the intersect. You can send it to the Python window, and it'll show you the code, or I can just copy the code. So if I say copy the code, and I'll just put it in here for right now, you will see that it'll actually give you the code that you would want to put into ArcGIS, the ArcGIS notebook to make it run. The one thing you'll notice though is I'm not using the environment manager where they're setting the Scratch workspace. I've actually set the workspace. I thought I did up here, but it's going to use the current workspace that I'm using, which is going to be that geodatabase. So I just don't have this line here in there, but otherwise the code is the same. And you can very easily run a piece of script, look at this and copy it over and really get your code in line in the way you want it. So if I was to run this right now, you're going to see I'm going to run academic footprint home locations are what I'm going to use, and that's in my contents pane. I'm going to intersect it with California counties. I want it to be saved to the path, which is going to be that default directory, and it's going to be called ANR footprint intersect. And if I run this line of code, it'll actually do that using the Jupyter Notebook. And now I've got the ANR footprint has been intersected, and it tells you where it saved the output. In a similar way, if I want to summarize the intersected data set using ArcGIS, I can set the table name I want to use. In this case, it's going to be ANR footprint intersect stats. And I'm adding that to my path. And this is that string substitution I showed before in my basics. And the output is going to be the default geodatabase plus this inside of it. And once again, if I copied the text over, you would see it mirrors that. I'm going to do the ArcPi analysis statistics. It's going to be on the output from the previous step. I'm going to save it to the path. And here's what I want it to do. I want it to be academic title, count, and my case is going to be name and sim title, just like we did in the graphical user interface. And if I run that, it'll perform the analysis for me. And you can see where it saved the output. And if I was to look in the catalog, go to databases and open this up, you can see there's the intersect, there's the intersect stat that we've added into there.
Shane, take
Yes.
a breather, and there's a request here just to slow down a wee bit. So
Yes, ma'am.
yeah, just let everybody catch up, see where we're all at.
Okay. Yeah, please let me know if I do that. Thank you.
So is everybody, let's do a thumbs up. How are we doing on, is everybody caught up to where Shane is?
Yes.
Give me a yes, thumbs up. Good, got some thumbs up. Doesn't look like everybody is. Okay, so let's take a moment and
I'll take a
get
moment.
everybody caught up.
Yes.
Yeah.
Thank you.
You could do what you did again, maybe. That'd be
I have a
useful.
question actually real quick.
Yeah.
And I think it's looking at sort of at this output and thinking that the stats table, your output table is actually the first thing you're defining, and then you're actually running through the code, where I think in some of like the GUI interfaces, you're specifying your inputs first, and then your output is almost the last thing. Is it almost say it's the reverse within the coding?
Yeah, you could do it different ways. I tend to define these variables first, and that's because I'm often using them in loops. So by defining them this way, I could easily move this inside of a loop and loop over something numerous times. So I would change a variable, which would then change what's put into this function. And then it would then loop through and do it numerous times. So I just tend to define my variables first. And then I add those into the, in this case, the path variable gets added into that statement. Did that make sense?
It does. Yep. Thank you.
Mm-hmm. And I mean, theoretically, you could you could combine all this together and just put it right here instead of this path, and it would work the same. Any other questions before we move on? Okay, so I'm going to try to slow down a little bit. So now we have the statistics table just like we had before. And if I was to open that up, we'll see the same thing. We're going to see the county, the symbolic title, and the counts. This frequency piece gets added by the tool automatically. So theoretically, we didn't have to have count, but we do. So we have frequency and we have count. Excuse me. And now if we want to go in and we want to work with this in pandas, which instead of using ArcGIS, we're going to use a third-party package called pandas. We are going to first reference the feature class. And in this case, it is feature class is what we're going to be referencing. And we define that up above, which is going to be ANR footprint intersect. That's the feature class. And we're saying use that name, and it's in the default directory or the workspace. And that's what in feature is going to be. And when we run this, it'll print that out. And then what we're going to do, and I'm going to minimize this just so we can see it fully, is we are going to use the in pandas, which is the alias is PD. So we're going to set up a pandas data frame. It's going to be a spatial data frame from a feature class. And the feature class is this intersected ANR footprint layer. When we run that, it's going to create a spatial database frame. And then the next line is going to rename sim title to be position title to make it more meaningful and easier to understand what it means. And we're going to do that in place. And what that means is we don't have to set a new variable. We don't have to set a new data frame. It's just going to do it in that data frame and save it. And then this very last line, we're just going to say display the last, I think it's going to be 5 rows. If we said head, it would be the first 5 rows. And if you put a number in here, it'll be that number of rows it shows you either in the beginning or at the end. So if I run this, what we're going to see is it's going to give us a data frame, spatial data frame. You can see what it's bringing in, which is in features, because we told it to print that. It creates a spatial data frame, and the spatial data frame has all the fields we had before, and it's renamed that sim title to be position type. So those are all the things we asked pandas to do and Python to do. So now we have this table and we have everything we need inside of a pandas data frame. Let's now go in and summarize it. In ArcGIS, we did the summary table. We created the summary statistics. So what we're going to do here is we're going to do a version of summarize called group by of the data frame. And we are going to group by name, which once again is county name, and then position type. And we are going to count up the number of academic titles in there. So that's what all this does. We're saying group by, county name, position type, and give me the count. And this right here removes the index that pandas creates and sets it back. Basically, if you want to think of it as a flat table. This next line is not going to print the shape as we picture it in GIS. It's not an XY, it's not a polygon, but this is the shape of the data frame. So the number of rows and the number of columns. And then once again, now we're going to show the top 10 records instead of the last 5 that we did previously. So if I was to run that, what we're going to see, like I said, is we're printing the shape. So there's 147 rows. And there are 3 columns. And here are the first 10 records. You will see Alameda County, the advisors, specialists, community education specialists, and their counts by academic title. The same thing we did before with the summarized table, but now this is in a data frame inside of pandas. So now what if we wanted to ask some other questions of the data? We didn't do this in ArcGIS, but we're going to do this here in pandas. What if we want to know the county with what counties have the most positions, or what counties have the least positions? We could easily do that just by running this line of code right here. And we're going to say, give us a group by position type. We're going to look at academic title, and then we're going to take the ID of the max, and then we're going to return the locations of those. And then we're going to do the same thing, but we're going to do the ID of the min. So if I run this, you're going to see that Fresno has the most advisors. YOLO has the most specialists, because that's where Davis is. YOLO has the most community education specialists and so forth. And if we do the same thing with minimum, you're going to see who has the minimum number of each one of those things. Really simple line of code to get your results. Now let's say we wanted to look at how many positions are currently under recruitment and in which counties. We have in this data set like where we are, ANR is looking at recruiting people within the next year. If we were to run this data set, what it's going to tell us is, first off, we're going to say we're subsetting the data to be under recruitment. We're saying look at the data set that has by county and the counts. We only want those that equal under recruitment in position type and save that as under recruitment. Then we are going to sort them from high to low, ascending, false. Then we are going to create an output, and we're going to do string substitution. So there are currently X number of positions under recruitment in X number of counties. And we are going to use the under recruitment academic title sum and under recruitment academic title count to get at those values. And then we are just going to give us the top 10 of the values for under recruitment. And that's what you see here. Now, let's say we wanted to go in and do something a little bit different. We want to graph those results, kind of similar to what we did with the horizontal, with the stack chart above when we worked with the Esri charting tool, where we came up with a chart that looked like this. But let's do that using pandas and matplotlib. In order to do that, though, we need to create a pivot table. What I mean by a pivot table, it's going to be, you're going to have each county, and then instead of having duplicate counties like we had above underneath when we looked at Alameda and so forth, instead of having Alameda 5 times, and then the position type, and then the title, we want to have Alameda once. Each position type would be its own column, and then the value under those columns would be the total counts of each one. So we need to do that in pandas using a pivot table. So here we're going to use the pivot table function as part of pandas. We're going to pass in the spatial database frame, the spatial data frame, not database frame. The values are going to be academic name. The index is going to be county name. So we're going to want county on the row index. The columns are going to be position type, like I described just a second ago. And then we are going to aggregate function is going to be the size. So that's basically the count. And then if there's nothing there, there's nothing in that county for that position type, we're going to fill it with a 0. And then we're going to sum those things up. So we're going to create a table. We're going to add a new column called sum. We're going to sum across each one of those items. And so that'll give us a total field. And then we are going to sort that resultant table by sum and name, and it's going to be high to low. So we should see the counties with the most on top, followed by, and then going down from there. And then the last thing we're going to do after we created that, we sorted that table, is we're going to drop the sum field so it's not part of it going forward. And then we're going to show the first 5 records. If we run that, what you're going to see is very similar to what we saw earlier. YOLO has the most, and then you can see CE specialists, advisors, specialists, and so forth going across. But like I said, we did drop the sum field that was out here that we used to sort. Now that we have that table in the proper format to do the stacked bar chart, what we're going to do is we're going to take that database, that spatial data frame, or that spatial data frame in pandas, and that data frame is called table. And you can see that here as well. And we are going to do a plot. And what kind of plot? We're going to specify a horizontal bar chart. We're going to say stacked equals true. So instead of like with the ArcGIS one where it went up and down, with the stacks, we're going to go left and right. We're going to specify size, and then we're going to specify 5 different colors. And these are by hex code. And that's what the bars will be. So here's going to be the title of the graph, and then the X and the Y axis label. And this very last thing is what you have to do to get it to show inside of your notebook. So if we run this, it's going to create that chart for us. And what you'll see is Del Norte is on the bottom, is at the top with the least number of positions, and YOLO is on the bottom with the most number of positions. So it's a really simple way to create a graph inside of pandas with a few more options specified. So that's how you could do the analysis, both using the GUI and ArcGIS, or the third-party packages. In this case, it would be pandas, it would be matplotlib, as well as the ArcGIS, the Python API for ArcGIS. Any questions on that?
Sounds good.
Okay.
Looks like everybody's cranking.
Fantastic. And feel free to play with any of the different options. You know, obviously it's yours to play with and have fun with. feel free to ask questions. So now let's shift gears. So this was using ArcGIS, data stored in ArcGIS Online and using ArcGIS Pro. And the next thing we're going to do is we're going to delve into actually making calls to external APIs and then working with those data both inside our ArcGIS directly using the GUI, as well as using the Jupyter Notebook, ArcPi, and those and that Jupyter, I'm sorry, not Jupyter, the Python toolbox within the notebook itself. And that would be, if you go to the catalog, that's going to be number 3, KalAdapt lib intro. Okay, so if we shift to that, I'm going to close down to first notebook. I'm going to hit save. And what we're going to use here, and this is actually a notebook developed to interact directly with the KalAdapt API, which is hosted and managed by the Geospatial Innovation Facility at the University of California, Berkeley. And this tool here that you see, KalAdapt Python Toolbox, can interact with the API as well as download the other data sets that are housed on their data server as netcdf files. So in this specific notebook, we are going to interact with the API itself. So if we want to use the API, what we're going to do is we're going to open up under toolboxes. You're going to see KalAdapt PYT. If you go to the first option there where it says KalAdapt API, expand that. And what we're going to do is we're going to say get data from API. And the first thing that's going to happen, and it may take a few seconds, is it's going to go out and it's going to query the API and bring back the most recent resources list. And it's now on my machine. So what I'm going to do here for this analysis is I'm going to take 2 select research extension centers in California, and I'll make them more obvious so you know where they are. They are in the extreme south and the extreme north of California. So if we're going to see any differences in climate, it's going to be extreme north, extreme south. So you can see the locations here, Modoc County and Imperial County. So we're going to use this thing called select recs in the that's in the contents. So if I go back to this, my input features are going to be select recs. And I'm going to choose process features individually. If I did not do that, what the tool would do is it would create an envelope around those 2 points. And as you can imagine, that envelope around those 2 points would be the size of California. And the KalAdapt API will not provide results for any area larger than the size of San Bernardino County. So that would error if we tried to do it for the entire state. So by saying process features individually, another added benefit is it'll process them one by one and add the values to a table, and then we can compare the different research extension centers. So make sure you choose process features individually. And then I am going to choose my category field is going to be name. The variable I'm interested in this case is going to be air temperature, or T air. And for right now, I'm going to use the global climate models. And you can see if you hover over the name, you'll see an indicator button show up, an indicator icon. If you hover over that, it'll explain, it'll actually give you a link you can go to learn more about the global climate models. In this case, I'm going to use GFDL, and it's going to be CMIP3. Same thing with period, I have to choose a period. If I hover over that, it'll actually tell me the different aggregation periods I can use. And if I hit drop down for GFDL, the only options are monthly. Other models, other variables, you can have daily, monthly, yearly. There are different periods you can use. And in this case, I'm going to say, give me historical data as well as emission scenarios, 4.5 and 8.5. I'm going to say give you all three. And once again, if you want to know what those are, hover and it'll explain. And then I want my aggregate type to be mean, and I want the data just to be saved as getData.api. And if you hover over that, it should tell you where it's going to save it as well. And if you hit run, it's going to make the call to the API. It's going to get the results back as a JSON input, or a JSON output from the API. And it's going to convert that and save that into a file geodatabase for our use later. And it'll take a few seconds. And when it's done, it'll add a table to the standalone tables on the left. Okay, so now we have get data has been added. And what you'll see if you open up that table is you're going to have the location name. So desert is the Southern Rec Research Extension Center. You can see the daily data. Here's the variable. There's the climate model. And you can see it's a historical scenario, the mean statistic, and the value and its units. And you have that for both locations, and you have 150 years worth of data. So now that you have those data, let's create a chart of them. So there's another tool inside of the KalAdapt Python toolbox underneath KalAdapt API, and it's just simple called chart. So I'm going to choose that get data API table we just produced. So it's going to be, and I'm going to choose the date field, which is date time. The category field is going to be name, so that's going to be the Research Extension Center name. And the value field I want to show is going to be the value field, which is going to be in, I think it was degrees C. So it's going to be the temperature. If I run this, what it's going to do is it's going to create the chart and add it directly over here to your standalone table. And if I open that up, you're going to see the chart for each one of the recs. But it's going to have a lot of data, and the data is going to be all over. So what you can do is if you go and you click on it, you're going to see data, and we are going to aggregate the data just to make it easier to read, because this is daily data of 150 years. We're going to go in and we're going to aggregate by date. And we are going to do, for right now, let's just do mean date. And right now we can leave it just at the default of 10 years. So this is the mean date. You can see how air temperature is going to change from 1950 to 2100 for both desert rec in Southern California versus the northern rec of Intermountain up at the Oregon border. So that's all been done using the Python toolbox within ArcGIS Online. But now what if we want to do the same thing, this time using a Jupyter notebook or a notebook in ArcGIS? So we're going to do that. There's a few things we're going to have to do. First is we're going to load the libraries again. So this first one is the operating system package from Python. It's a standard package. We're going to load up ArcPi, pandas with an alias of PD, NumPy, which is a numeric array package, and it's used for dealing with large numeric arrays. And in this case, we're going to alias it with NP. We're going to bring in matplotlib for plotting, and then once again the Python API for ArcGIS. And we're going to import glob. I cannot remember what glob is to save me. But we're going to import that because that's going to help us work with the paths that we're going to need for finding the library, the KalAdapt API for Python. So here, if we run this, what's going to happen is we're going to import those libraries. We're going to set our credentials for using the Python API for ArcGIS. We're going to hook into the current project. We're going to find where the California KalAdapt Python notebook is stored, load that in. You can see we're importing that toolbox, and we're going to import it as KalAdapt. And then we're going to import also, there's a KalAdapt helper library that's been built, and it's called Cal. And there are numerous functions in there for working with the API as well. And then we're going to go in, and our geometries are going to come from the select recs, which are coming from our default geodatabase. And then we are going to do the get request again, very similar to what we just did earlier. But we're going to say ArcPi KalAdapt API, the KalAdapt toolbox. We're going to call get data API. Here's the geometries we're passing in. And once again, we're saying split the features. We're going to split. We're going to use the name as the field for splitting. We want the temperature of the air. Here's the climate model. Here's our period. And then this has to do with historical, RCP 4.5, RCP 8.5. So it's the exact things we said earlier in the GUI. Now, if we run this, we'll get the same result. And there are some deprecation warnings that it tells you about. When it's done, we should end up with a another data set, except for this is going to be called Get Data API Single. And I'll explain what that means in a second. One of the interesting things about this is, you know, until recently, I did not know you could actually reference and call custom toolboxes directly in Python using ArcPi. And this is the one method that I figured out that works really well. So just keep this in mind for any of your own toolboxes you may develop and use, and you can use them in your Python code. So now it's done. And you can see that right here we have the Get Data API Single. One thing to also note here is if we want to chart that, we can chart using the same function we did before. However, you can't do that if you're not in ArcGIS Pro, because it needs to know what's in the, it's going to test the map to see if that table's in the map or in the contents. And if it's not going to chart it. So this has to be run from within Pro. So if I run this right now, what we're going to see is it'll create a chart just like we did before. Here's the exact same chart, and we would modify it in the same way as earlier. So if I open that again, do the aggregate and just say mean and do 2 years, it's the exact same chart. But this time it's the chart, but we're using the Jupyter notebook to generate that chart. One caveat though, let's say one of the issues of the Python toolbox, when you go and you create the chart, you can't have more than one model added, because every time you try to run another model, it clears the table and adds again. Excuse me. So let's say you wanted to run for both desert and Intermountain, you wanted to look at multiple climate scenarios instead of just the one. There's a potential way you could do it is run it and save them to individual tables and then merge those tables. Or you can do it via Python instead and actually redo it and do it solely with Python and use the helper application, the helper module. And you could actually script it to do as many climate models as you want and add them all to one data set. So, excuse me. So what we're going to do here is the next several lines of codes are, we are going to go in and we are going to actually go in and create an output table that's going to have, for multiple locations again, it's going to have multiple climate models, multiple scenarios, and all in one table that we can then graph. So the first thing we have to do is make sure we have a fresh resource list. And like I mentioned, the tool will go out if your resource list is greater than a week old, it'll create a new one. Mine's not, because I think it actually already recreated it when we opened up the toolbox and ran the first tool. But it'll actually, if you run this line of code, it'll do it for you. Now what we are going to do is we are going to actually create a well-known text format of the geometry of both those recs, the Research Extension Centers, because that is what the KalAdapt API needs. It's either GeoJSON or it's well-known text. So there's a helper function inside of Cal called create WKT. You pass in the geometry, you tell it whether or not to split, and once again, what field name to split on, in this case, name. And if I run that, it's going to go and it's actually going to create a WKTS representation of those geometries. And you can see them if you want, if you were just to zoom in to one of these locations. And there's that there, the green polygon is the well-known text format. It's just being plotted so you can see it. So once you have that, then the next step is to reach out to the, find out what resources are on the API and get it formatted in a name for the, get it in the proper format for the call. So here we're going to do something, we're going to call the get resource name. So we're going to tell it we want, once again, T-air, so air temperature. This time we're going to use Miroc 5, which is a different climate model. The period's going to be monthly. And the scenario is going to be RCP 45. And if we add those things in, you can see you've got where you want it saved. Is that right? Let me see here once. No, that's the home folder is the location of the resource file. Here's the variable GCM period and scenario. And if we run that, what you'll see is you'll get a help that explains what it is. Excuse me. And if you want to see what that actually returns, uncomment out that last value. Oh, where resource file is not defined. I missed something. We will not uncomment that for right now. I must have missed running a line of code above, but it would actually show that file. And this is how you run it. And then once you have that, what you're going to do is you're going to tell it, you're now going to do the request to the API and have it return the data. And what that requires is the WKT, the well-known text format geometry, and then what you're asking for. In this case, we want the mean statistic and we want the KalAdapt file name, the output of this KalAdapt request above. So what resource? And if we run that, it'll return the results for us. Pardon me. And if we want to see the results, I'm going to insert another line below and I can show you the results. So I just type results, hit enter, and here are the results. So it's all the information in a JSON output. You don't have to worry about that right now because we actually have ways to drop that into a table. And that's actually what we're going to do next. So we have the JSON representation from the API. But now what we're going to do is we are going to create a table and push those data into that table. So once again, if you want to see how to write that function, what the syntax is, type help, and then the name, and you can see it. The workspace is going to be the default geodatabase. We're going to call the table get data API 1. And then we're going to, the outputs of that, beyond creating the table and dropping the data in, it'll also save the parameters to use in the charting tool if you want to do that. If you don't save this as a variable, it won't stop the tool from running. You just won't be able to use the charting tool that we have built. So if I run this, it's going to run. And what you're going to see is it'll take a few seconds, but it's going to create a new table. The new table is going to be added. It's going to be called Get Data API 1. And there it is. It's not quite done yet. It's now populated the data. And if we want to see, pardon me, if we want to see what those data look like, what the chart parameters are, just insert another table and run and just type that variable name in. And you can see these are what the charting tool is going to use: date, time, climate description, value, and the table name. And now if we want to run that and get a chart, we've got it added to the table. We're going to come down here. You can look at the syntax again, or we can just say cal create table, and it's going to be parameter 1 for all the parameters that are in that that list above. So you've got 0 through 3, so 0, 1, 2, and 3. And if I run that, we now have a chart created as part of that process. And if we open that chart, you can now see all this is the individual data. So now we've gone through and we've defined all the steps that you'd require to work with an individual data set. But now let's put it all together and create a table that's going to go out, and it's going to go and query the API for two different climate scenarios and 2 different climate models and 3 different climate scenarios, and save them all to a table. And all we're going to do is
we break right before we do this one to make sure everybody's caught up.
Maggie, that is an absolutely fantastic idea, because I could just
maybe you can get a glass of water.
You mean I can't talk? Let's take a 5-minute break and I'll get some water.
Okay.
Thank you, Maggie. Okay, so let's start back up. So one thing you'll notice is the last several cells we've run, we've been actually testing and building out a process. As Maggie mentioned, Jupyter notebooks are really good at doing that. You can create one cell, test something. Does it work? Does it not? Go back up and modify it until it works. So what we've done here from steps 1 through step 6 is actually create the process and get all the code working for what we're going to use next. So the next step that we're going to do is we're going to take each one of those 7 cells above, or excuse me, 6 cells above, or steps, and we're going to combine them together into one cell that we're going to run. So what we're going to do is we're going to first, once again, define the resource list like we did above. We're going to set the workspace. In this case, it's going to be the default workspace with the project. We are once again going to set the geometry to be the select rex. And this could be anything as long as it's less than the size of San Bernardino County, and it needs to be in California for this specific example. The table name is going to be get data from the API multiple. This time we're going to have a list again. This list is going to be a list of 2 strings, and those strings are global climate models. This is going to be GFDL, CMIP 3, and MIROC 5. And we're going to run 3, we're going to have it pull back data for 3 different scenarios. And once again, another list. It's going to be historical, RCP 4.5, and RCP 8.5. The variable we're interested in is going to be TAIR. The period is going to be monthly, and the stats are going to be the mean. Now, any of these, whether it be the variable, the month, or the stat, we could have a list of different things, and we could loop through those using a for loop and get all that other information if we wanted to. So in this case, we have all those variables set right here. If you're familiar with R, you could select that and just run what you have selected. In Jupyter notebooks, you cannot do that. If you were to run this cell, it's going to run everything. So be careful. If you just want to set variables, add it to a separate cell and run it there first. Okay, so here you've got all your variables set. So the first thing we're going to do is, once again, we are going to create the individual WKTS, or the well-known text format of that geometry. We are going to set the output table location. So we're going to take the table name and the workspace and come up with where we're going to save it, which is going to be called table. And now, because we're not using Esri's tool to check to see if a table exists, because their toolbox does that automatically, and it deletes it if it exists, and you run the tool, we're just going to say, does it exist, yes or no? If it exists, we're going to delete it, but then we're not going to delete it after that. We're just going to empty it out the first time if it's there, and then everything else are just going to get appended to that table. So this is how, using ArcPi, you test to see if something exists, and then you decide what you're going to do if the Boolean operator is true. So this gets back to what we talked about with a Boolean operator in the basics. And once again, I should note, here's the equal thing I mentioned before. So does it evaluate to equaling that? Now what we're going to do is, you can see in my code, we are going to loop through each one of the GCMs. So the first time through, it's going to be GFDL Simit 3. It's going to run through the loop. The second time, it's going to be Muroc 5. We're also going to have a nested loop inside of this. We're going to loop each one of the scenarios. So it's going to be historical first, then RCP 4.5, followed by RCP 8.5. And then we're going to have another nested loop. So we got 3 for loops here in a row. We're going to do it for each one of the geometries for the REC and the Research Extension Center, Intermountain and the extreme Northern California, as well as Desert REC in the extreme Southern California. So we have 3 nested loops, for loops. And then inside of there, we're going to say, okay, we need the resource name we're interested in, and we're going to pass in the resource name, the resource file location, the variable we're interested in, TR, the GCM, which we get from the for loop, the period that we set in a variable, and the scenario that we've got from the for loop. It's going to come back with the resource name based on those values. And then we're going to pull the data back from the API using the WKT that we're looping over, the well-known text, and the stat of mean. And we're going to save those as results. And then the next step we're going to do is we are going to go in and we're going to pass that into the results into the KalAdapt create table function that's been written. And it's going to append that to the table that we've set up here. And it's going to do that over and over and over again. Then I have this thing here, and this is the first time I've actually mentioned this anytime so far. We have a try except code block. And what this does is it says, try this piece of code, in this case, try to chart the data. If it's not in a map, if it's not in a, if you don't have a map that has that chart in it, so in other words, ArcMap's not open, it's going to throw an error. And this is the error it's going to tell you. So when we run this, it's going to go and it's going to create, and it's, I mean, it's not going to create, it's going to go and it's going to do 1, 2, 3, 4, 5. So you got six different requests, so 12 different requests to the API. And it's going to pull those data down and put them into a table. And this is going to take a few seconds. And this is something that you can't do with the KalAdapt Python toolbox directly, just because of the way ArcGIS handles toolboxes and the checking for data existing or not. So you have to use ArcPi and Jupyter notebooks to do it. And this is going to take a few seconds. Oh, it's done. If I come over here and let me do 2 things. It's still doing something. Okay, so I'm going to zoom out. So it's all the way out. What you'll see now, we have another table, and the other table is called Get Data API, and we have a chart created. If we open that chart, it's going to have a lot of information on it. And let me go in and we are going to modify that chart slightly. That's a lot of information. Let me open that up again. And so let me see if I specified any options to set. I did not. So what I'm going to do is I'm just going to go in and change the aggregate. I'm going to give median, or maybe I'll do max, maximum, and I'm going to do my aggregate is going to be, excuse me, let's do 25 years. So here's 25 years worth of data. And you can see, so you got T-Air monthly, here are the different models, here's the different locations. And that's what it looks like right now. So the upper ones are desert rec, the lower ones are Intermountain. A little hard to interpret. You could probably do some tweaking to this to make it a little bit better. Let me see. Now we'll leave it there for right now. So that's using the GUI to do it. I mean, using the charting function of ArcGIS Pro to create the chart. But now let's say we want to do the same thing this time with a spatial data frame using pandas. What we are going to do here is, once again, like we did before, we are going to load the table in as a spatial data frame. And before the data was in degrees C, we are going to do a conversion here on the fly. We're going to take the spatial data frame value, the value field, which is in C, and we are going to convert that to Fahrenheit. And we're going to save it back to that value field. And we're going to change the units to be Fahrenheit instead of C. And then we're going to sort the data based on value, and it's going to be descending. And let's show the last 5 rows of that data frame. So we're going to run this. And here's what you see. So we have now gone in and recalculated the degree C to Fahrenheit, added the units, and we've sorted it. And now what we're going to do is we're going to go in and we are going to resample the data, because right now the data is daily. No, it's monthly. Sorry, it's monthly data. We are going to resample it, and we are going to resample it annually, and it's going to be every 10 years. So it's going to be an annual sample, but I guess it's decadal. Every 10 years, it's going to sample it up, and it's going to take the maximum value, and it's going to be based on the date time field. And we're going to group by GCM and by name. And then when we're all said and done, we are going to drop out the date time field. We're going to drop the GCM field. We're going to drop the name field. I got to remember why, but that seems to be what we're doing. And let's see what that looks like. I didn't drop it. Bear with me just 1 second. Why? Trying to remember why we had to drop those. I think the group by might duplicate those. That doesn't make sense. But yeah, so in fact, we could look at it. If you wonder why, you can always rerun the code. Yeah, so I see. So it creates, we're basically doing a couple things. We are dropping the fields from here, from the data table itself, the name, the date, time, and GCM. And after we drop them, we're resetting the indexes. So we're taking GCM, name, and date, time out of the index, out from being an index, and they get added back to the table. So if we don't do that, you get an error. So by dropping them, it's allowed to run and do what it's supposed to do. Okay, that makes sense. So now we have decadal data. You can see here we have the GCMs, the rec names, in this case, desert, and then you have every 10 years. And you can see it's the start of the year. So it's going to be February, it's going to be 1950, January 1 through 1959, December 31st. And it's going to give you the mean values of degrees Fahrenheit of air temperature. And you now have that table for every 10 years for both those models and both those centers and all the RCP values. Now that we have those data, it's saved as SDF2, that is the data frame, we are going to plot that. And so we're going to do a little bit different things. We're going to set a value for figure and axes, and we're going to do subplots. I'm not going to get too much detail about plots, but this is using matplotlib. You can look more into that. But essentially, this is going to, we're going to do a group by. We're going to go through and map the data based on GCM and name. And then we're going to have title, and we're going to label the axes, and we're going to create the graph. So it's much cleaner. It's a much cleaner graph than this. But what you can see now is GFDL, CMIP3, and you can see for what's going on at desert and Intermountain when it comes to climate data. One thing you may notice is that we've combined RCP 8.5 and 4.5. We've taken the maximum values of those. We could redo that and actually split them out. So you had 4.5 and 8.5, but we haven't done that here. So it's a much cleaner graph and you have more control of it. Any questions on this last piece? Okay, so that is using the API and Jupyter notebooks inside of ArcGIS and ArcPi and a Python toolbox, which I've glossed over the fact that the Python toolbox is also built using Python itself. So there's a lot of Python being used here. So now the last Jupyter notebook we're going to go over is the KalAdapt Growing Degree Day exercise. This one will require some setup on your behalf to get it to run. And I'm going to go through that here real quick. There's two things I want to show you. The first one is I'm going to put a link in the window, in the chat window. This is a deep learning framework that Esri puts out that works with ArcGIS Pro. This deep learning framework has one of the packages that we use in the fourth notebook. It's called Dask, which allows for really efficient parallel processing of very large data sets. So if you use this installer, you could download it, install it, and it installs all the packages needed for deep learning inside of ArcGIS Pro. It's a very handy thing. And the link is in the window. But I'm going to show you how to do it just in case you didn't want to install that packages. Earlier, Maggie had mentioned Python environments and how to manage them inside of ArcGIS Pro. We are going to go through that now, and I'll show you how to do that. And the notes are also in the fourth Python notebook. It mentions environments and how to work with environments as the first piece of it right up here. So if you go to the project, what you're going to do is if you go to project and then you go to Python, it'll take a few seconds, but it's going to show all of your Python environments on your computer. And the reason you have to do this is the default Python environment that Maggie highlighted, which was ArcGIS-Py3, is the Python environment used by ArcGIS by default. It has all the packages that are needed and are used and are available by default when you install ArcGIS Pro. If you want to add additional packages, you have to clone that because that is a read-only environment. You can't add new packages. The only caveat is if you run that deep learning modeling framework installer, it can actually go in and add to that default environment. But if you just want to add a new package, you actually need to go in and manage your environment, clone it, and then add your packages after that. So one thing you'll see here, I clicked on the manage environment. It opens up the manage environment window. And the first thing you'll notice is I have several. I have 2 that don't have a red stop sign next to them. And I have 2, and then I have 3 that have a red stop sign. The red stop sign means that either it's an old version of an ArcGIS environment from an older version of Pro before they made compatibility between switching versions, or it's a Python environment that does not contain the ArcGIS packages. So these 3 that I have that are flagged as red are because they're standalone environments not used with ArcGIS. If you want to clone your environment to add packages, the first thing you need to do is clone this one here, the ArcGIS Pro Pi 3. If you hit clone package, what it's going to do is it's going to clone it. It's going to name it for you, and you can't control that name. It's going to give you ArcGIS Pro -Pi 3-clone. Not very helpful. It'll work, but instead, if you choose the clone button on the side, it'll actually give you the option to save it where you want. This is the default location for environments, but you can also give it its own name, and a much more meaningful name, such as I did here with deep learning, because I'm using it for a different, some deep learning exercises. You hit clone, and it's going to take a few minutes. It could take 5, it could take 10 minutes to clone that environment. Once it's done, as you can see here, it tells you it has to restart Pro for that new environment to take effect. And once you do that, you're up and running. But I'm not going to actually change my environment because I actually like that I'm in the deep learning environment. So now let's say you're in your new cloned environment. One thing you need to do is you need to add another package. To run that fourth Python toolbox, you need a package called Dask. And if I look in here and if I look at installed packages, you'll see that under installed packages, I have Dask. If you haven't installed the deep learning toolbox, you will not see Dask as a tool that you have access to. So you'll have to install that. To do that, you go to add packages and you do a search for Dask. It'll then come up with a list of things that you have not installed yet. You could do Dask, the full version of Dask, or just the core. You would select it and say install. Give it a few minutes, it'll install, you should be good to go. Every once in a while, it'll error and it won't install properly. You may have to use a different method for installing your packages. And I've highlighted that in the document you got in your email. You may have to do a conda install from the Python command prompt, which I showed you earlier, or a pip install. And I've highlighted that in the instructions as well. But yes, you're going to have to install Dask to run that last piece, the last Jupyter notebook. So assuming you have Dask installed, and you can see I wrote some instructions here of the best way to do it, then what you can do is you can actually complete this notebook. So what we're going to do in this notebook is we are going to go in, we're going to pull back netcdf data from the KalAdapt data server. And we are going to, which is netcdf data is gridded multidimensional data set. It's a gridded data set that covers Nevada and parts of Nevada and all of California and the surrounding states. And it's multidimensional. It could be a month's worth of data. It could be a year's worth of data, but it's a large slug of multidimensional data. And it's all of a certain type in this case. So what we're going to do is we're going to download those data, and then we're going to do a growing degree days calculation on it. And in this notebook, we actually load in an ancillary heat units Python module that I've written. That uses growing degree day tools that have been vetted about 30 years ago through UCANR. And we'll use that on these data sets. So the first things we need to do is we need to load the standard imports again. You've seen all of these except for, I think the only one you probably haven't seen is Xarray and import lib. Those are 2 new packages that we haven't used yet. Xarray is a module for efficiently working with multidimensional array data such as netcdf. And import lib utility is a module for importing libraries that are not in the not on the Python path, and it's an easy way to import them into your project. So that's why those two are also there. So I'm going to run that. Okay, so there's a runtime warning. It should still run fine. I haven't had any issues. So those were the standard libraries, and now we are going to load in the heat units Python script I was telling you about, as well as the KalAdapt Python toolbox. One's going to be loaded as HU, so for heat units, that's going to be the alias, and the other one's the alias is going to be KalAdapt. So now I've run that, and they're both in place. And here is a function I've written that checks for the location of a folder where you're going to save data. If it doesn't exist, it'll actually create it for you. So that's a helper function. And then here we have it so that if you pass in a date range, it's going to test that that date that you pass in is whether it's historical or a future scenario. So it knows which data to pull back from the API, whether to look at historical or RCP 4.5 or 8.5. So we're going to load that into the project as well. And then we get into this large function. I know one of the things in our slides that we presented was don't put too much information into a code cell in Jupyter Notebooks. That was kind of a thing to think about. I broke that rule on this specific one. This one function does a lot, but I've tried to explain the different steps that it's doing. So for anyone who wants to work with netCDF data, I've got functions in here that are going to deal with slicing and dicing your data and having start times not be January 1 through December 31st. So there's methods in here for choosing different start and end periods of a date range. And you can see that in the beginning here. I also show you how to merge different netCDF data together. And then, just basically how to work with the data. I also have how to convert data. So when I'm merging the data, it's pulling back the netCDF data itself. It's then, when you load it using Xarray, it takes every netCDF file you have and combines it together. So now this data set's going to have both T-min, as you can see, the air temperature min and air temperature max in it. And this is going to be in degrees Kelvin. So we convert that to Fahrenheit. So all these different steps are in here that help with actually creating the growing degree day calculation part. So I'm going to load this function, and we'll be calling that later. So this is apply GDD function. Let me see this. And then if you want to learn more about that, you can go and check out what's needed for this cookbook. So right here, this function is now going to go in. This cell is going to go in. It's going to, here's a tuple of variables I'm interested in. So this is TAS min, TAS max. So air temperature, and maximum and minimum. Here's where I want to store the data. We're going to check to see if that folder exists. Here's where I want to store the end result, the resultant data, GDD netCDF. And then here's it's going to check to see if that exists. And then here's the GCM and the scenario I'm interested in, the future scenarios. And here are the years. So I'm setting all the variables, creating all the folders. So I run this, and that's been done. The next piece, and I'm gonna avoid this last piece because it's going to take about 10 minutes. But I guess I could let it run and we could talk through it. So essentially what we're going to do is we are going to loop through the years. So we have 2 years in this list. We have the beginning year and the end year. And you could actually do it for the entire time span from 1950 to 2101. It would take probably a good day to run. I say hours, but most likely day to run. But so here we're just going to do 3 years worth of data. It's going to go through, loop through. It's going to download the data using one of the toolbox functions called locadata. And it's going to actually pull the data back and store it on our device, on my device. And then the last step is once it saves the data, is it's going to be for each year, and it's going to increment through the years. It's going to apply that growing degree day function. And it's going to save the results to a folder on my computer. It's going to save the netcdf data and the growing degree day data. And then once that's done, once that function finishes, what we're going to do is we're going to load that up into an individual data set called DS for data set, very descriptive. And we're going to do a cumulative heat units. And we're going to plot that for a plot. So we can look at over time what's happened at this one location of latitude and longitude, and we'll see what it looks like. And then, in fact, what I'll do is shift to the project I've already got this completed on, so I don't just have to talk through it. Give me one moment. And we'll let this run in the background. So I'm going to reshare, and I'm going to choose the right notebook. Can you all see my screen? Okay. So here we've run the tool, and now we've gone in and we've merged all the data, all those netcdf files, we've pulled them together. And this is all the outputs of the growing degree day calculation. And now we're saying plot the data with this latitude and longitude, or I should say location data in that array. And here you can see what it looks like. You can see growing degree days increasing over time. So this is October, then you have the winter hit, and then once the spring starts, you see growing degree days increasing rapidly. And then it starts over the next year on the water year of October 1, and it does the same thing. And so you could do that for every year. And then the other thing we do, we show how to resample the data into a different time frequency. So here we did it. This is done monthly.
And then come up, you grab onto both legs.
Okay.
And then.
Hey, Sean, could you mute, please? And then on this one, we're going to take the same data set. Actually, that was daily data. We're going to go and take this daily data, and we are going to resample it to be monthly data. And we're going to take the maximum value per month. And this is a resampling function from Xarray. And we're going to actually plot the same data. And you can see it's very similar, but it's a lot less data to be working with. And here we're using, you can see the lat long, which is 80/80, which is confusing, but there is the lat long. And you can see the data. And then if you want, because it's in an Xarray multidimensional, you can also show the data on a map, not just for one location, but for the entire state. So here is the entire state, including Nevada. So we're looking at growing degree days. What we're going to do here is we are going to load all the data up into the file, and we are going to save it to a new file name that is essentially taking these variables. We're going to save it into the project folder with the name of the GCM, M for monthly, and then the years. And the output will be a one netcdf file, and it's going to have all those years in it. And then we can plot that file, and this would be the very first date. So this would be October 31st of 1950, and here's the number of growing degree days for that entire range. And we could do the same thing again and just change the date. We could say date, 30, and it would give you the data from 1953, anything you want, and you can start plotting the data that way. And the nice thing about ArcMap is it can also work with netcdf data, and you can import it directly and visualize it as well inside of ArcGIS. Any questions? I know I did that last one fast. There's not that much in terms of steps. A lot of it's in that main function that I just kind of walked through. And you can see that this one is still running. It's still creating the data on the back end. So it's still downloading and applying the function. Now, one thing we didn't cover in this workshop, and I think that it's one thing that I use a lot, is automating map production with Jupyter notebooks as well. In ArcMap, in ArcGIS Pro, I'm sorry, not ArcMap, you can automate map production very similar to a map series, but you can change just about every item in a layout. You can change data sources, and you can reproduce map series really quite quickly. As a prime example, there's one project I've worked on where there were probably 250 maps as part of the project. Luckily, I had automated the steps using a notebook inside of ArcGIS Pro, and the team that was working on the project wanted to make one change that had a ripple effect through the entire modeling process. And within less than an hour, I was able to reproduce the analysis plus all 250 maps. So by automating that process using a notebook, it drastically sped up the entire process. And that project alone really sold me on the utility of notebooks inside of ArcGIS Pro. But like I said, I didn't cover that here. Any questions with 10 minutes remaining?
How are you guys doing? Anybody, any of the folks who are still on want to comment on how far they got, or?
I'm curious as well.
Yeah, how was this? Was this useful? Are you going to be able to use these notebooks later? Great.
Good.
Great.
Yeah. And I think I think this was great in stepping through, and it's just needing more time to go through it and look at it in sort of the context of our own work as well.
Yep.
Yeah, absolutely.
That's the beautiful thing about these notebooks. So take them, modify them, make them to work with your data.
And if you play with the KalAdapt Python toolbox, and let me know what you think about that. If there's anything if you have any glitches with it, I haven't yet, but if you do, let me know. Please kick the tires. Let me know what happens.
Yeah, Andy just posted in the chat. We're going to send this out in email too, but we would love to get your feedback on the workshop, because we take the feedback really seriously. So if you've got a moment, please click on that link. And there wasn't a question earlier. The recording we save the recording, we post it on our YouTube channel. We'll make all that available to you. The slides are available. We love hearing how your projects are going. There's other workshops. I'll put that in the chat. And we also have office hours. So if there's something you want to chat about later, we love hearing from you. So that's the training schedule for the spring.
Yes.
And so there's other ones happening. And we also have office hours if you want to pop in and chat about stuff.
And just so you all know, the process I kicked off earlier that's been running in the background just finished. So it takes about 10 minutes to run.
Very cool, Shane. I always love watching you do your magic.
Thank you.
Well, thanks so much, everybody. This was a fun and inspiring week of UC data love. And we really appreciate you being here with us on a Friday afternoon. Have
Thank
a
you all.
great weekend, you guys.